And welcome back to Mr. Gregoris Math. Today we're taking a look at using partial factoring to help us find the vertex of a quadratic. So here we have a quadratic and it probably looks something like this. We know that it opens up because it has a positive a value. We know that the vertex is not on the y-axis because of the fact that it has a b value other than 0. And we know that its y-intercept is -2. So if I had a y-axis here, I would know that, sorry, I don't know where it's actually going to be. It's going to be here. I would know that the y-intercept at that y-axis is going to be at -2. So partial factoring takes advantage of the fact that we know that the quadratic has to go through this spot twice. So there has to be another spot where I have the coordinates that also have -2. So we're going to use a process to help us find those coordinates. And that process is just a couple of steps. First step, we're going to set y equal to -2 because we were searching for that spot where it was -2. So I'll have -2 equals 3x squared plus 7x minus 2. And now I'm going to solve this for x. Now technically I'm solving a quadratic right now, but it works out to be a little bit easier because of the fact that I'm only going to have 2 terms when I'm done. So I'll add 2 to both sides to get rid of these. They cancel, neat. I'm left with 0 equals 3x squared plus 7x. So on this step, I have to remember that factoring is religion and... Wow, they dropped the ball on that one. Okay, so we'll common factor. There's an x common to each term because there's an x in the first and last term here. So we'll take out an x. Now there's no common factor between 3 and 7, so we'll have to leave 3 and 7 like that. But when I remove x from the first term, I remove it by division. So I had x to the power 2, I divided by x to the power 1. I subtract the exponents and I'll be left with x to the power 1 in the first term. I didn't do anything with the 3, so it has to stay there. Now I'll remove x from 7x by division, so that's going to leave me with positive 7. So this leaves me now with 0 is equal to something times something else. So that means that either something is 0, because one of the two has to be 0, or something else is 0. So I know one of my locations where y equaled -2 was at x equals 0. And if you remember my quadratic that I had here, this -2 was there because it was our y-intercept. So this was actually the point, 0, -2. And I'm actually going to find the other point from this part. So what I'll do is I'll solve this for x. I'll subtract 7 from both sides. They'll cancel. I'll be left with 3x equals -7. And then I'll have to divide both sides by 3. And I'll get x is equal to -7/3, which is about -2 1/3 or -2.33. So the coordinates of this point right here, that same height, are -7/3 and -2. So I now know 2 places where this quadratic goes through a y value of -2. Great. I'm going to erase this part here, but this is the first step of finding the vertex. The second step is a lot easier. All we have to do is say, okay, I know the axis of symmetry is going to run right down the middle of these 2 points, and it's going to pass through my vertex. So I need to find the x-coordinate of my axis of symmetry. To do that, I'm going to have to take the average of my 2 x values. So I have to take the average of 0 and -7/3. So I'll add them up. 0 plus -7/3, and then I'll divide it by 2. Now this looks like a tricky bit of division, but I know this is the x value of my vertex. So 0 plus -7/3 is -7/3. Dividing by 2 is the same as multiplying by 1/2. So I end up with -7/6. Yuck. Now you can use your calculators and get to a decimal approximation in some classes. Some teachers may want you to leave it as a fraction. I prefer fractions, but my current class probably prefers decimals. So they likely would have changed this to negative 2.333, and they likely would have changed that to 1.16666. But we'll leave this as negative 7 over 6. So that means that the coordinate down here is at negative 7 over 6, and we just need to figure out the y coordinate. And no, it's not 0. We just need to figure out that. So fortunately, we have a rule. The rule is, if I want to know what y is, I just have to substitute in an x value there. So now we're going to substitute x equals negative 7 over 6 in y equals 3x squared plus 7x minus 2. So what that'll look like is 3 times negative 7 over 6 squared plus 7 times negative 7 over 6 minus 2. Now I have to do some calculating here. So I would get on my calculator and type this out. Unfortunately, I don't have a calculator here with me right now. So I'll wait a second for someone from my class to do this, but I'll just probably approximate it in my head here. So this is 49 over 36, so 49 over 12. So that's like 4-ish. And this is 49 over 6, which is like negative 8-ish. So that's like negative 10-ish. So it'll be around negative 6-ish will be the answer, is what I would presume. Now we just have to wait until someone types it in. Grady, can you throw me your calculator? When you're typing something like this in your calculator, you always have to be careful that you don't make a mistake with where your brackets are. So we need to make sure that that squared applies to the negative 7 as well too. Otherwise, we're going to end up with an issue. I'm not using my favorite calculator in the world here. What did I say? I think I said negative 6-ish? Negative 6.083. So negative 6.083, repeating, is our y coordinate of our vertex. So we could write that in here as well too. Negative 6.083. And we should make a statement. The vertex is negative 7/6. And if I wanted to change this into a fraction just to be super cool and do fractions, I could probably just press this button and sorry, I'm using a calculator I'm not used to. No. I'll have to leave it as negative 6.083. Oh, and close my brackets. And that's it. So it's a little bit of a process to find the vertex. We had to do some common factoring. We had to do a little bit of algebra and some substitution here. You'd be welcome to use decimals in some classes, and other classes you might have to use fractions. But this is just one way to find a vertex to give you a quick sketch of a graph. And that's it. Join us next time. Don't forget to hit like and subscribe and smash that notifications button. What is it? Smash the like button and subscribe and hit the